everybody. Thanks for having us here today. I'm Susan from Holo-Light, and this is my colleague Evan from AWS, and we are today talking about the business-ready industrial metaverse to you.
Good morning, AWE. As Suzanne said, I'm Evan. I'm a specialist for spatial computing at AWS, so focus on all things go-to-market strategy, business development, some product strategy. And as you mentioned, yes, we're going to talk about building an enterprise or industrial metaverse. And it's funny, we gave a similar talk on this last year, and we didn't use the term the metaverse, or the M word as I call it. I actually made fun of the term, but here we are embracing it. We lost the battle to marketing yet again. But I'm curious, by quick show of hands, how many here actually embrace the term metaverse and use it freely in their organization? Not that many, okay, a few. And how many of you have actually shunned the term and avoided it like the plague, have renounced it? Okay, more than I thought. I think I won that bet. That's awesome. So for those of you who embrace the term, we're going to talk to you about how to build this mythical experience. And for those of you who are a bit more pragmatic, perhaps, we're going to talk about some actual business challenges and technical challenges that we're addressing to really unlock the power of not just AR or VR, but 3D more broadly, and help you tap into this really underutilized utility that exists within 3D and all your existing 3D assets. Most companies that make a thing already have 3D data, but it's woefully underutilized, and we're going to talk about how to change that today. So at Amazon, we always like to work backwards from customer pain, customer problems. So we'll start there. I think, Suzanne, you guys have a perspective on the main customer challenges at your end.
Thanks. So to start from the beginning, if the clicker is working, amazing. Why is XR not already used in a way it could be in enterprises? The answer is pretty simple. We are all used in our daily lives to these amazing experiences from computer games, from advertisements, from any software we're using. But all of these need tons of processing power. We have kilograms of weighted PCs for that stuff, and now we want the same experience from a device sitting on our nose. That's not really working out how it should. Also, we have already now several of amazing experiences for apps, several applications and XR in different companies. But they are all floating around. Each has an app. Everybody is taking care of his app, but they are not centralized. So if you want to get a new application, want to see, hey, Evan, I have seen you have this cool application. Where did I get it from? You never really know where to find it. Also, you can't just use applications with demo content prepared from somebody else. You want to use your own content, your own ideas, your own products, your own creations. And that all leads to the problem. There's currently not the approach for a scalable rollout right now. But there's also the other side from the infrastructure.
Yeah, we're seeing the same problems, Suzanne, especially within verticals where there's just really heavy, dense 3D files like automotive or aerospace and defense or healthcare, med devices. And as people go and start to solve the problems you mentioned, they quickly run into a whole new layer of problems at the back end, at the IT layer. The most infamous one is the speed of light problem that humanity has not yet figured out how to solve. So we got to figure out how do we bring compute closer to users. And then if we're going to offload compute from the devices, right, with this whole new proliferation of wireless headsets, which is great, they don't have the compute power, as Suzanne mentioned, but IT and InfoSec gets their panties in a bunch when you go take your valuable 3D product data, your IP, and send it off into the cloud. And so how do we create the right parameters for security around this data? How do we keep it in your firewall, perhaps, such that InfoSec is not having a tizzy fit? But the most common problems we're seeing that are the most fundamental across really every vertical, every use case is really around 3D workflows, or really the lack thereof. Particularly 3D model and asset creation and different types of transformation that goes into that, and then the management of that 3D data. So I spend a lot of my time at Amazon trying to educate people who are new to 3D to this customer pain. I've been getting in conference rooms, going on whiteboards with people, and we end up with some abstract art that looks like this when I try to explain to them how 3D assets move throughout a life cycle in an organization today. People are using USB sticks and email attachments and share drives. They're trying to move 3D assets across design teams and manufacturing teams and training teams and sales teams. And you have different people in these groups using different types of tools, not talking to each other, and it's just an absolute quagmire. So it really looks like this, complete spaghetti. So what customers are asking us to help them do is something a bit more aesthetically pleasing. They want us to create a more unified system, something that connects all these disparate tools for 3D, all these existing workflows, existing systems holding 3D data, and connect them into one unified workflow, one unified system that we call a 3D first digital thread. Something that can be a single source of truth for your 3D data to help you get the right 3D asset to the right place at the right time in the right file format. And what we like to say is that our main job at AWS is to help you democratize access to 3D data. At Amazon, we like to talk about customer problems and then ask the 5 whys. And we drill into the why this problem exists. And pretty quickly, people start to ask me, what's unique about 3D data, right? Don't tools already exist to manage it and convert it? Like, what about PLM systems? And the system is that they're just not cutting it, right? These are old, curmudgeon-y tools that are built for desktop environments. They're not cloud native. They're expensive. And they're not really built for the layman, the downstream user in sales or marketing who needs to get a quick 3D asset for an e-commerce experience or for a VR training experience. And so what they want is something that gives them more control over all the different variables of 3D and something that's more input agnostic. I'm not sure if you can read that. That one's legible. But the ability to ingest all kinds of data types, right? Sometimes you have data like CAD. Sometimes you don't. You need photogrammetry. Sometimes you have point clouds, right? How can we have something that can be input agnostic? And then, how do you give someone the required dexterity to produce assets in all kinds of ways for different use cases, right? Editing the textures, the materials, the polygon count, and then getting it out into any kind of file format. This is what the ultimate 3D pipeline to us looks like. It doesn't really yet exist until, hint, hint, soon. And what we're seeing, though, is once customers address this problem, it actually exacerbates an entirely new problem, right? Let's say you create an automated 3D pipeline for any data type. Now you have this waterfall of 3D content and 3D assets. But there's no good way to now organize around that new layer of data. And so what customers are asking us to do is help them build out something that unifies both the ingestion and optimization process with an asset management system in a very flexible and very modular way. So those are some of the main challenges we're looking to address. We'll hit the solutions in a minute, but first, Susanne has some content to share.
So after talking now for a couple of minutes, I think it's time now to show you what we're talking about. And we want to introduce to you XR Now. Which should work now. No. With XR Now, we have built the most powerful immersive streaming platform. And how does it work? So basically, you need an XR application, obviously, and you need the streaming technology. Our streaming technology is called Iser. It's a simple SDK. You can download it directly online and integrate it in your application. And you already have an XR Now application, which can be hosted on XR Now and streamed directly to all connected end users. With XR Now, we are uniting AR, VR, MR applications, different 3D engines with streaming and the cloud with all industrial relevant XR devices. But what's inside? What did we need to build up something like that? Of course, I'm from Holo-Light. I'm outlining we are needing streaming. We need Iser. But there's also in the background, there's a lot more. There's rendering, there's resource management, user management, orchestrating, PLM connectors. Luckily, we have a partner on board with AWS who's supporting us here, and I would like to ask Evan to show us more here.
Indeed, yeah. So there's a whole bevy of services from AWS that are powering XR now on the back end, right? From our storage services, database services, compute, API services. But these are really all abstracted away from you as the end user to create this sort of Netflix for 3D type of user experience. I think what's more interesting for you guys is what we're doing upstream and downstream of this application to solve some of the challenges from earlier. So as we've been engaging customers alongside Holo-Light, customers are asking us to help them build a custom and bespoke 3D ingestion pipeline and asset management system. They're telling us there's just nothing out there that's a one-size-fits-all approach, right? Every vertical, every customer has unique requirements around security, unique 3D data types, certain use cases and existing workflows we have to account for. And so we started to build out these systems, and while there's no one-size-fits-all approach, there are a few key set building blocks that repeat across every single one of these systems we've developed. Customers want an API-first approach to, as Susanne mentioned, integrate with their PLM tools and their downstream applications. They also want the ability to bring their own license or their own tools for 3D CAD conversion or photogrammetry or LiDAR meshing, you name it. They also want just a really basic system to act as like a 3D data warehouse repository where they can search and configure and easily share 3D assets. So we started to build this for about 6 to 8 customers over the last 7 or 8 months or so, and it was getting pretty redundant. So we stepped back and said, why do we keep doing this? Let's just build it ourselves such that we can get customers further along towards a production grade system. And so that's what we did. We've actually built a 3D asset management system that includes an interface to build and drop in your own custom 3D ingestion pipelines and create your own workflows. We call it VAMS, which stands for Visual Asset Management System, a very sexy, creative name we're pretty proud of. And we've actually are now in the process of open sourcing it, right? So you can have access to the code and customize it as you deem fit. But don't think of this as a solution out of the box per se. Think of it as more of a modular framework out of the box, where you're going to get the ability to easily upload and manage 3D assets with our storage tools like S3 and DynamoDB. You're going to have the ability to visualize in a browser and bring any kind of rendering tool like Babylon per se of your choice to visualize. But not just visualize the model, also see all of its derivatives and see all the associated workflows tied to it and all the pipelines that are tied to it, right? And all the different model hierarchies associated with it. Where it gets really interesting is the ability to, like I said before, drop in your own pipelines with containerized code, which is basically just a packaged script that allows you to run an application in the cloud in a very scalable, horizontal way. So take, for example, services like Pixies from Unity or Unreal Datasmith, right? We can now containerize these things, and rather than doing one file at a time on one workstation, you can upload hundreds of files, parallelize all the compute and all the containers to process those, and create hundreds of files within minutes that are XR ready. And then different pipelines are needed for different use cases, different data types. So let's say a certain workflow is, upload asset from PLM system, convert to this file format, reduce this polygon count size to this, add this texture and send to XR Now or different applications in XR Now. That's one workflow. And today it's a very manual process to build that out time and time again. But with this system, you're able to bake that workflow into one script, and that's now a one-click workflow for that particular pipeline or use case. So that's how we're solving the 3D workflow content creation management problem. Downstream from this, we talked about latency and security requirements. It's important to note that Holo-Light runs very well in the public region, the central cloud. They have incredible technology that does what's called late latching, that creates a much lower perceived latency than the actual latency on paper. So for most use cases that aren't super interactive, they're mostly visual, you can run Holo-Light in the region. But some use cases are a bit more twitchy, a bit more interactive, and sometimes InfoSec has a strong stance once the data on-prem. So for that, we have a whole slew of edge compute offerings. We have our Outpost offering, which is the same hardware and software stack from our data centers. We drop into your data center or into your manufacturing facility or your design environment or into a retail environment. And it acts as the ultimate little hub for remote rendering and streaming. I call it spatial computing in a box. But sometimes that's overkill. You don't need compute right next to the user, so you can kind of work your way back a little bit to our local zones offering, which is now a cluster of outposts in these smaller data centers that are located strategically in busy metropolitan cities, right? LA, San Francisco, Houston, you name it, close to where your employees might exist and be working. A problem that oftentimes you run into, though, is that sometimes enterprises have really old wireless networks. So there's a bandwidth constraint. And so for those customers, what we can do is actually offer 5G offerings now. We have Wavelength, which is our public 5G service with partners like Verizon, telco partners. We've actually dropped Outpost into their what's called a MEC, Mobile Edge Cloud environment, into their data center with our cloud services so you can stream over 5G. Or if you need private 5G, you can use Outpost, drop it into your data center again or your factory environment, drop in some 5G hardware and software, and boom, you have your own private mobility, private network via Outpost. And then lastly, some customers, like in manufacturing or in defense, they want something at the far edge, something that's ruggedized, something that can work in a disconnected environment. So for that, we have our Snowball Edge family with GPUs in them. You can run at the far edge and then bring back and connect back into the cloud to download or send back data and applications. Now, this proliferated compute strategy is very important for what is one of the more foundational elements of most use cases, which is remote collaboration, right? Especially in today's post-COVID world, people all over the globe trying to collaborate, and so this is when edge compute becomes even more necessary. And I think, Susanne, you have some content around the remote collaboration use case.
That's true. So if we put all these parts together, what does it look like? And we want to show you directly one short demo of XR-Now. We're heading towards XR-Now. We choose our engineering solution and software, and we're already connected. We can see the avatar, our colleague Daniel, who is already connected with us, and we are both working together with the stored files on the cloud. So the whole application and files are rendered and streamed directly from the cloud to both of us, so we can directly work with each other, no matter where we are based, in which sites of our companies we are right now, and that's basically XR-Now. But we just don't want you to just trust our words, so we asked one of our customers to join us today. Unfortunately, he's not on site directly with us, but Kurt, can you already hear us?
Hello, thank you for having me. One of the major factors we now face is that advanced visualization solutions are becoming a known commodity. Like the rise of the PC and the smartphones, we now have a world of software engineers constantly creating and deploying visual-based applications. The industrial metaverse, like digital twin, everyone's got their own definition. My own elevator pitch version is simple. It's a set of technologies that can help deploy XR and visual applications at scale. This means deployment of solutions to thousands or millions of users, and it's not about one single piece of software to rule them all, but hundreds of them that all do their part together. The metaverse concept should be the same. It's not one single app, and the way I see it, it's more of an extension to the existing DevOps pipeline, but specialized in visualization. So, why is the metaverse different than what we got today? Well, visualization applications are uniquely challenged because of the complexity of the content they serve and their intense hardware and network needs. It's also about seeing information in new ways, which means high throughput interfaces and data threading with systems like industrial engineering PLMs, manufacturing MESs, and sustainment MROs. Solutions today don't tackle those aspects well, or at all. This brings us to technologies like remote rendering, a great example of a needed infrastructure component. It can reduce end-user hardware needs, content preparation pipeline bottlenecks, and help in areas like decreasing cybersecurity risks. It's similar to commercial streaming platforms today. Most major media and gaming platforms are using streaming for a reason. Industrial-based companies will be no different. Now, remote rendering is not the only thing needed in this architecture. However, once you start combining it with cloud and edge compute, mobile 5G, and systems that can easily deploy many different XR applications, now that's starting to become a recipe for a newly scalable DevOps environment. My biggest sticking point, though, is that visualization scalability is not just a development team responsibility, but based on my experience, is more of an industry-wide IT challenge. Organizations need to seriously look at these metaverse technologies as native infrastructure components or risk major future IT bottlenecks, even to existing operations. So with that last point, I'll end on a question. Is your infrastructure upgraded to handle visualization? Because deployments for new applications are going to start piling up, and I can guarantee that the developers at this conference are making sure of it. Thank you, everyone, and have a great conference.
Thanks, Kurt, for outlining the importance of a technology like XR now. Also, there's more use cases and more different verticals for this technology. We wanted also to bring one of our customers, Enhatch, today on stage. Unfortunately, Peter could not join us, but he provided us with some amazing content. But a small warning, if you're sensible to surgery and medical visualizations, please look away for the video, because I don't want anybody of you to throw up and keep that exhibition that way in memory. But let's see what Peter will tell us.
Hello, my name is Peter Verrillo, CEO and co-founder of Enhatch. We are perfecting surgery together with our partners, our customers, our surgeons. At Enhatch, we're developing the intelligent surgery ecosystem, which connects artificial intelligence, augmented reality, virtual reality, all these technologies that are becoming mainstream into a solution for our customers. And we're leveraging Holo-Light and the technology that they bring with XR streaming into our tools around virtual reality and augmented reality. Today, we're going to show you a little bit of both, but I'm really excited to be virtually here at AWE, and I'm looking forward to what that's going to mean for the future of the medical device industry. Now, over 10 million lives are affected every year by musculoskeletal diseases, and there's a need for over 80 million patients each year to be serviced. So globally, the technology is not yet available, but we believe that by bringing the cost down, by bringing the technology into a higher level, we're going to be able to see incredible opportunities to help all 80 million patients every year. And we're really starting in the orthopedic and musculoskeletal space, but we're quickly expanding into other areas. We have an exciting new set of partnerships we're going to be announcing, just like this one here, that's going to keep driving the ecosystem further and further. So again, as I said, we are perfecting surgery together, and let's begin. In 2022, virtual reality is coming to the Enhatch ecosystem. This allows surgeons to virtually train on the patient's anatomy using the actual instruments designed for that surgery. This enables our customers to leverage one cloud solution to deploy all of their marketing content to any device, delivering a personal experience for the surgeon to review and prepare for any surgery. Augmented reality is also going live, allowing surgeons to easily bring the patient's radiographic imaging, including X-rays, MRI, or CT, directly into surgery without the need to look away from the surgical field. The technology allows the surgeon to quickly align the instruments next to the actual bone, giving them the confidence in the placement of where the implant should sit and the bone they must remove. By combining 3D printing with augmented reality, we're able to provide a more accurate clinical outcome for the patient and the most efficient process for the device company, the hospital, and the surgeon. Thank you for allowing us to share the future of surgery with Enhatch.
It's good timing for lunch. Yeah.
Perfect. Now some steak. To sum it up, AWS and Holo-Light, we are together bringing to you the industrial-ready metaverse. Holo-Light is providing the platform and the streaming technology, and of course our expertise in the enterprise market.
Yeah, and we are, like I said before, bookending Hololight with value in the form of globally available infrastructure and compute upstream with 3D asset management and 3D creation pipelines, and then downstream a portfolio of edge compute services to lower latency. And yeah, thank you all for coming. If you guys want to see a demo of the VAMS offering, drop me an email or find me on LinkedIn. My email is simple. It's just evanaws@amazon.com, evanaws. Happy to set that up.
Thanks. So to come to an end, I'd like to invite you, make your step into the Industrial Metaverse, meet us the next 2 days at our booth in the sponsor area, and talk to us directly to book your private demo at AWE. We still have a few slots open, and let's stay in touch with us. You find us on LinkedIn, on social media, and in our offices, Germany, Austria, and since a couple of weeks, also the US now.
All right, guys, see you out there.
Thanks.